Hey guys, welcome to the second episode of Context Talks. Today I have with me Tony Seale. Hello, Tony. How are you?
Hi, yes, I'm very good, thank you.
Right, good to have you on Context Talks. Tony, before we get into it, right? I wanted to understand a bit more about your background because you seem to have spent a considerable amount of time inside investment banks, Lehman Brothers, Deutsche Bank, Lloyd's, RGS, right? How does somebody who has worked in investment banks ends up becoming the knowledge graph guy on LinkedIn? How did that happen? Tell us more.
I guess like all of my career have been around data integration, and so I've always interested in that area. And it's obviously a big thing within investment banks because they were early adopters of like information technology, and that's both a blessing and a curse. So essentially, you have like so many of these different siloed applications and databases, and then I would spend a lot of my time kind of stitching them together in order to get stuff done for traders. And
Mhm.
it was while I was at Deutsche Bank that over a decade ago now, so a long time ago, that I just thought there must be a better way than this to solve this problem, and began experimenting with using like the idea of knowledge graphs and ontologies,
Mhm.
and the whole thing just kind of like snowballed from there really into something that I've now just for the last decade I've just been absolutely obsessed with the idea. Initially, I wasn't even convinced it was something that was going to work. I was quite surprised how well it was working.
Yeah, just it. Thanks for that. Right. Well, Tony, help me understand when did you realize that the problem wasn't with the model? Because I still see, Fable was released again to public a few days, yesterday or 2 days back,
Yesterday, yeah, I'm busy. I've
right?
busy got like loads of Fable stuff running now on my subscription. Yeah.
Yeah, and we see engineers and AI teams behaving as if that this is what they were waiting for, and this is what was blocking their agent in the production, right? And they've magically or it seems like they've outsourced the problem to the model, right? But I want to understand, when did you realize, right? Or what triggered that realization that it's not the model, it's the data?
Yeah, I mean, I guess so. I have been working at this for an awful long time now. And my hypothesis was always like, it was before we had large language models, but my hypothesis was always I can see that like what we were calling machine learning back at that point was growing more and more powerful. And this was going to be like a huge force that was going to be coming in. Um, I guess my second realization was that the people who were training these, which was quite a lot of Google, were really pushing ahead at that point. And I was kind of looking at it and thinking, well, it's all right for them because they've got these vast data sets from everything that they're doing. You know, you can just get like hundreds of millions of users all doing exactly the same thing, and you can go pull everything that's written on the internet. So I began thinking about the problem being inside an investment bank. How does that translate to this situation, and just this kind of like fundamental nature of the fact that with a machine learning model, it's not like what we were doing with like deterministic programming where we would like write programs and test them out. It was like, no, this is a different paradigm where data needs to be fed in order for these things to predict well, and therefore it's kind of like obvious, well, then what an organization needs to do is it needs to have lots of data that's going into if it's going to be able to use AI correctly and train AI correctly. And then it kind of builds from there, because then it's like, okay, if the data is sort of what we call heterogeneous, so it's this kind of like complicated domain specific data, how on earth do you turn that into lots of data? And then it kind of, the next kind of logical conclusion, inescapable logical conclusion from that is, well, I need to connect all the data together that we have got. So at the moment, it's in all these separate places. So to make that really big, then I need to connect it together. And I guess the sort of final part of that then is that I went to knowledge graphs for the fact that they could connect information together. I didn't go there for the ontology part, but it starts becoming apparent that given that you're not going to have as much information or as many samples as like the big foundational players have got, then you'll kind of have to put more information in about it. So you're going to have to define semantics. You're going to have to take some of that information that's sitting in people's heads at the moment, and you're going to have to encode that in. So that was my sort of like background that's gone back for an awful long time now. And then when the first version of large language models came in, and I started kicking the tires with those, because before that I was using, as I say, like machine learning and early versions of GNN and stuff like that. But when like the early version of ChatGTP came out, and I saw a lot of noise about that. So I thought, well, I'm just going to try it out to see how that combines with this technology. And it was like, wow, this is really big. Like a load of the stuff that was very difficult for me to do before now being kind of like solved by this thing. And so in some ways, I'm super excited about Fable coming in. Like each time we get a more powerful model coming in, that is a big deal, and suddenly you can do more. The realization that sort of slowly dawned upon me is that that's like rented intelligence. So you don't own that intelligence. But then the
Yeah.
question becomes like, well, what is it that an organization is going to do that's going to preserve the IP? And yeah, you could train your own models, and some people do, but there's a certain kind of brittleness to that. Like if you're training your own model based upon like a foundational base, you're going to have to keep kind of retraining it if to do some kind of continual learning. Whereas there's in some way a cleaner and simpler solution, which is that basically you connect your data together into this what some people call context graph, but really is just a knowledge graph. And then you organize it, and the learning effectively is now occurring in a symbolic form within your ontology. So that's something that humans can inspect over, and you're retaining that IP within your organization.
For my audience sake, right? You use the word ontology and you speak about it obviously very, very passionately, and you have written about it extensively on LinkedIn, on your blog, and your website. Uh, a lot of people listening think about ontologies and taxonomies as English words. It's very difficult for them to relate these concepts as things living inside an AI agent, if you know what I mean. Can you break that down for the audience? Like, what is it? How should one attempt to understand those two words?
Yeah, absolutely. I mean, first of all, I guess I should say before like starting with the definition that the argument of whether this is the right thing to do or not is now over. It's completely won. So you've got the Databricks ontology, you've got the Snowflake doing like an OSI version of the ontology. Amazon's doing something. Google's saying you've got the Microsoft ontology. So there's no there's no kind of doubt now that this has kind of gone from like a niche thing to consensus amongst all of the major players that
It's
this is the way forward for conveying meaning to your AI agents. So then, what is an ontology? It's conceptual model of your world. So if you're in the business of running trains, then the conceptual ontology is about tracks and trains and the speed that they're going and signal boxes and all of this sort of thing. If you're a hospital, then your ontology is about patients and beds. And so whatever kind of niche that you're in, and that can go down to like a really low level. So maybe you're in law and it's about like these very precise legal concepts. You're in engineering and it's about like these very detailed things about how a machine fits together. Whatever that area is, it's getting very clear about those concepts and also how those concepts relate to each other. So we're not just talking about a schema like you would put in a database table here. We're talking about a rich conceptual model that is linked together, and more than that, it's done in a formalism. So natural language is super powerful, and that's what the large language models are dealing in. And we can kind of say anything that we want to in natural language, which makes it
it's
very, very powerful. But it's not a formal language. Computer language, for instance, is an example of a formal language, or mathematics is an example of a formalization. And with those, they give you the same results every time that you go execute them. So you go execute a computer program, it's going to give you the same results. You go execute a mathematical function, it's going to give you the same results. You put certain parameters in, and it's going to give you the results over. And that's what we call like a formalism. And then, so what an ontology is it's using first order predicate logic. So it's using logic, this sort of like 2,000-year-old idea of logic, and it's putting that into a formalism, such that we can like deterministically say, if I've created this conceptual model of the domain that I'm interested in, now making that domain verifiable, I can ask questions of it and I'm going to get the same deterministic answer back. Now, why is that important? Well, it's kind of good on its own, but it's rocket fuel, it's dynamite once you pair it up with a large language model, which has exactly the kind of opposite thing to that. It's not formalism. It's based upon natural language. It can do poetry. It can go wherever it wants, which is like its absolute superpower. It can do these amazing things. But sometimes we don't want it going wherever we want. If we're in a precise domain within a hospital, and a patient is about to be issued a certain amount of drug, we don't want you being creative there. There's a very prescriptive path that you want to go down, and you must not diverge from it. If we're designing a machine or operating a machine, again, there's, yes, use your creativity to do the analysis of what's going wrong here, but like, no, don't put that cog there. That would be absolutely disastrous and would blow the whole thing up. And so there's this kind of balance that we want between like a formal specification and the creativity, and that's what ontologies are bringing to the picture, basically, like bringing together with the large language models the clear semantics of what needs to be done, but within this formal deterministic structure. And there's a lot of confusion about that now, because
Yeah.
ontologies have become very popular. Then you're seeing all sorts of people come in. I'm
Yeah.
an ontologist. I know about ontologies. Oh, we've added, like slap ontology onto their product or whatever. And people are talking very loosely about
Yeah.
the subject.
Yeah. Yeah, no, I completely agree, and I thank you for that amazing breakdown, because the one problem today is exactly what you've said, that because the word has become popular, now it tends to start losing its meaning. It's used very flexibly. People take all sorts of liberty to.
Yeah, I'm going to do it. I'm going to do a blog post soon with a jokey thing called Seale's law, which is the semantic value of a word is inversely proportional to the marketing value of that word.
I like that. I like
Yeah.
Seale's law. Right.
Yeah.
I also have with me Joshua Thomas. Joshua is CTO and co-founder at Switch. Hey, Josh.
Hey,
Hi,
Josh.
hi, Vivek. Hi, Tony. Good
Hey,
to
hey.
have you here.
Yeah, nice to meet you.
Tony, I've been listening to what you were saying. I've also been reading some of your posts as well.
Thank you.
You've previously spoken of LLMs and knowledge graphs, and how LLMs are continuous and knowledge graphs are discrete. Could you maybe illustrate what that difference is? Maybe also get into, for folks who are viewing, there's a lot of people using vectors and embeddings. So how would you explain, all of this, and how this comes together, like the difference? And yeah,
Yeah, so the continuous and discrete is in some ways a continuation of what I was talking about before. So but it goes right down to base mathematical level. So within mathematics, we can have a continuous representation. Think about like plotting. Like, let's maybe we're going to do like a chart, and we're going to plot house prices or something. Then if we did that like a line chart, that's a continuous number that's going there on the line chart. I could go and I could zoom in. Depending on what my granularity might, I could just, especially if I'm kind of like uh, creating that number, hypothecating that, I could just keep on zooming in on that forever. Or at this point, it's 0.1111, up to the amount of decimal points that you can do. That's a continuous representation. And at a very deep level, large language models are operating in a continuous regime. I'm not quite sure how technical your audience are, but like the back propagation algorithm requires upon the being continuous. And the embedding vectors that are created, they are continuous numbers. That's what those kind of like weights are. That's why they've got so many decimal points after them. It's like a continuous representation. We can contrast that with another part, another like this branching off of mathematics at the point of a discrete representation. So if we go now back to our like example of doing a chart, maybe we're going to chop up the house prices by postcode, or we're going to chop up the house prices by, I don't know, like the job title of the person working there. Or we're now basically going to go to a bar chart representation. But something quite fundamental has happened by doing that bar chart, because you've made like what in our terms, in our community, we call like an ontological commitment. But you've decided upon a category now. You're going to break those, you're going to bucket those numbers up into these discrete categories such that you've got like a bar chart. So why do I say ontological commitment? Well, you've decided that actually to really understand this information, I would like to categorize it by this. And then now what we've done when we've done that is we've put it into like a discrete representation. So if we think what's a knowledge graph and an ontology, when you're creating your ontology, you're deciding within your particular business or your particular world, what are the meaningful concepts to you? And those meaningful concepts, that's like you're creating a category for that sort of thing. I'm going to categorize and carve the world up in accordance with these things. And I'm going to, and then if I go get some instance data, so now create a knowledge graph. If I start extracting nodes out, those nodes are discrete items. So one way to kind of illustrate this, which I have some sort of diagrams on, but if like a large language model, there are trillions of parameters, they're absolutely huge. You've got trillions of these floating point numbers in there, and the concepts in them are kind of distributed across those. But if we simplified it down, and we imagined that in fact there was just two numbers in there, it gets simpler. We've got now a vector. Vector embedding has just got two numbers in there. And again, it doesn't work quite like this, but for simplification process, let's say that one of those numbers represented how fruity a thing was, and another one of those numbers represented how techie the thing was. And then we had like a bunch of terms, a bunch of words, and we're just going to plot those on a chart now. So we've got techiness going here, and we've got fruitiness going here. And then, so like banana is going to come really high on fruitiness and really low on techiness. And Amazon's going to come really high on techiness, but really low on fruitiness. So it's kind of hard to like try and mime this out. But what happens to the term apple? What's a large language model going to do when it comes to Apple? Are you talking about Apple, the company, or are you talking about Apple, the fruit? So in a continuous representation, the Apple will have to kind of sit in the middle, half techie, half fruity. So it's kind of blurred those concepts together. Whereas if we were to plot that in a knowledge graph in a discrete way, you would have two separate nodes, and those nodes would be associated with two separate types. So that's like this kind of like fundamentally different, like they're both networks. You've got a neural network that is a network representation with these probabilistic edges, continuous mathematical realm. And then you've got the same shape, the network shape, which is the shape that learning occurs in. But now you've got the discrete representation of that thing. And it's not like one is right and one is wrong. It's not like, oh, I only ever want to use line charts. I'm never going to use bar charts. Or I always want to use bar charts and never want to use charts. That's the way of looking at the problem. It's like I want to use bar charts and line charts. I want discrete and continuous mathematics. They're both useful, and I want to use them together actually and interchangeably.
So it's also some kind of certainty that we're associating. For example, if you're looking at it neurally, you should be looking at it only if you do not have clear categorical meanings or buckets that you can put those instances into. Right. And if you don't have that,
I wouldn't say like should or shouldn't. Like the way I think the most useful way to think about this, the framing I give around this is this idea of the neural symbolic loop. So essentially you have your neural representation, your continuous representation, embedding vectors, natural language, large language model, and then you have your discrete representation, knowledge graph, ontology, categories. And what you want to do is you want to cycle between those two representations. Each one's got certain strengths, so you basically move through the different representations in order to give the answer that is both grounded into your world model and your data, but is also intelligent.
Yeah. So in a real world use case, you need both because you want to generate a response that is holding on to both, right? That's what you're saying.
That's right.
All right.
Interesting.
Thanks.
Then I also want to go back to something you said earlier, which was own the ontology, which allows you to rent a model, right? Now, I was talking to a buyer today, right? Their specific approach to in their use case context was they would load everything into the agent's memory. But what they were adding there was eventually flat files, flat text being thrown into MD files. And it just seems like a lot of people are just like literally doing that right now as we speak, right? And it's there's a lot being said about memory is the moat and so on, right? And I remember you guys wrote about that in a blog last year, that the revolution in AI would be on the memory, right? But you had a different approach to that. You were not advocating for flat files, right? So I want to understand why. Like, what changes when you start thinking about memory, and what's the structure in that case?
Yeah, like first of all, that's another one that I called the memory, the memory one. I have other predictions going forward if anybody's interested as well. Like that's some big stuff. But what's the difference between flat files and organizing it into like a graph structure and an ontology? Well, I mean, the kind of flat file thing is the context that people call. So it's like if you're just going to go pile in a whole load of text, well, like first of all, what text are you going to go retrieve? How are you going to work that out? I mean, you could use the not old fashioned, but you could use the kind of RAG mechanisms of like the embedding vectors to pull that. And for certain use cases, that is actually the right thing to do still. But it's proven not to be sufficient in most cases for what people want. And then, so you want to think about, well, what is then a good memory system going to look like? And I would say that the first thing is that a good memory system is going to exist in a network structure. Why? Well, like that is the structure that learning occurs in. As I say, the neural network is itself in a network structure. Pretty much all of nature, like from trees to brains to the system in your body, is within like a network structure. There's something fundamental about being able to take information and connect it into this rich network structure that allows for learning, and that's what you want to do with your memory. So yeah, you've got your text there, reams and reams of text, but again, to take the kind of categorical approach there, what do you care about within that text? And two different people or two different organizations are going to care very different things about that text. Like one will, a lawyer looking through it will be interested in a certain set of concepts, and a finance person and a salesperson, again, would have like a different set of concepts that they're interested in. And when it comes to like remembering it, you want to remember the important information. It's like you don't want to just like remember everything. You kind of just forgetting is actually quite important. You want to remember the pertinent facts that are useful to you, and beyond the facts, like the kind of concepts that are meaningful to you that you care about. What are those? And then to the second point, it's like, well, those concepts and those facts, they don't exist in isolation. Data gets its value by being connected into other things. It's everyone talks about context. Well, what does context mean, really? If you kind of like go back to the original, it's important that my AI has context, and people kind of like chuck context around very, very broadly now. But like, think of what the word context means. Context means like how this thing relates to other things around it. It means the connections that this one fact has in relation to those other things that are around it. And then, so that's why the graph structure that you put it in, it's like, okay, I've got this fact, but how does this fact relate to everything else that I know? And now I need to go and put those network connections in so that when I understand this fact, I'm understanding it in the context of everything that is around it and it is related to.
The argument we're making is just throwing chunks of text is not good enough context.
What are you learning really if you're just throwing chunks of text at your AI, what is your organization learning? And I don't think the penny has really dropped for most organization owners yet, exactly how important and existential this moment is for them. That they need to be getting on with learning about what makes their organization unique, what puts them out of distribution with what everybody else knows, and they need to be consolidating that. They need to be connecting that information together, and they need to be doing, like, another one of my buzzwords, but they need to be discovering their ontological core. So, like, what are the core concepts of this business? What's the essence of this business captured within a formalism? You know, what separates you from the rest of everybody else? And now that's kind of formalize that and connect all of your data into it to make it a solid thing that we can pass to an AI agent. If you don't do that, and it's a big job, it's not something that you can just put an AI in and it's going to do it for your organization, because a lot of that information is tacit knowledge inside people's heads and it's distributed across all sorts of systems. You have to get on with this job right now, because if you don't, then you're not going to be able to function in the world that is very, very rapidly approaching us. And if you can't work out and consolidate what it is that you know and what the essence of organization and what sets you out
Yeah.
with other people, then you're not going to be able to bring that value to bear. And actually what will happen is it will just leak out of your organization, either by you let someone in by the back door. Oh, we'll come and learn your ontology for you, use our platform. Our ontology platform will secretly siphon the ontology out of your organization and into our platform, which will then go off and sell to everybody else in your sector. Or just you're so loosely put together that you don't really understand what's unique about you or what is important information, and some competitor in like a very near future will bring up some agent swarm that will go, it's not even the future, it's possible reality now. We'll bring up an agent swarm that will go ask loads of questions that hit different parts of your organization that you don't even realize are coming from one place, and they'll piece together what your strategy, what your IP is, and it will just kind of bleed out of you like, you know, like heat out of the body. So it's the fundamental move to do at the moment, and I've tried to find ways to convey it to business leadership, because it's really important that people properly understand.
It's a tricky message also at the same time.
Yeah.
It's a very difficult message to land on somebody, because another conversation which also happens in the same light of renting the model and owning the ontology or owning the intelligence structure itself is that of lock-ins, right? Conventionally, people used to be very scared of, hey, am I getting logged into Salesforce? Am I getting logged into ServiceNow? And so on and so forth. And you could still brute force export data in weird formats, do a lot of data manipulation, and move to another CRM. Painful process, takes time, months, but sure, it is at least possible, right? A lot of people are very confused about what would that migration look like if done for agents and the so-called agents context or agents ontology. Like, one, is that possible? Or is it as easy as going, let's just change the model endpoints from OpenAI to Anthropic and we'll do it there? Is it as simple as that? Is it more complicated? What does that look like to you?
Yeah, so there are a few things to say to this. Let me start with the first one last. Is it possible to swap out the different ones? Yeah, absolutely. I mean, I do that the whole time now. So within the knowledge graph guys, we have a powerful interconnected knowledge graph with everything that runs the business, and we have an ontology there. And I swap out Codex and Claude Code to be running through that network and that discrete graph of information, and be kind of give me information back. And they don't even know that that is like electricity, basically. The intelligence is just like electricity. The persistent artifact is the knowledge graph and is the ontology that we've created around that. So first of all, yes, absolutely, that part can be done. The second part, which is like how you actually storing down that ontology and that knowledge graph, that's a bigger thing. And this is where open standards are really important, and true open standards as well, because it's quite easy for someone to slap the term open in front of what they're doing and maybe a cohort of vendors to get together, it's like, again, you've got to be a little bit wary about that sort of stuff. There's a kind of tendency at the moment, what I notice with ontology, to kind of, we have a true open standards, a set of ontology and modeling ontology. It's in half of the web already. So most people don't know that, but like half, by people optimizing for SEO, half of the web pages globally have got little pieces of JSON LD within them that link back to the ontology of Seale. It's pretty basic ontology,
Yeah.
but it's out there, it's in mass production, it works. You've got to think, like, when someone's saying, "Oh, I've got my new ontology standard," we've got our XYZ ontology. Why is it that they're so motivated to depart from an existing proven ontology, which is working over half of the web, that 100% open by, not with no vendors in there whatsoever, by the W3C? That's,
Sounds like
there's a kind of intellectual process again that leadership needs to go through to just like compute through the motivations there.
these are hard choices that require a lot of domain understanding. I mean, I do know of a company that does what you said right now and sells to defense and the categories which are highly regulated. And they don't talk much about the format itself, seems like a closed source ontology. But it's very, I'm trying to imagine for the leadership to get so tactical on some of these choices, expecting such nuance to penetrate through leadership, right? And it's very easy to screw it up, right? It just
Yeah,
sounds,
and how many chances are you going to get? Everything's moving so fast
yeah.
that and it's quite a big effort to basically kick off this program, this transformation program within your organization. But yeah, a mismove here with letting a bad operate, and not necessarily bad operator, but like maybe an operator that's just focused on getting money for themselves, could be, you could be misled quite badly. And I saw that happen with the agile movement, where when we were initially introducing that, that an organization would say, they were doing like waterfall, and they'd be like, right, well, we're going to do agile. It was my kind of previous thing before I got into knowledge graphs. I was like involved in the early agile movement. I've obviously got a penchant for, or an interest in like these kind of ideas that seem like good ideas that then go mainstream. But with that one, what I noticed is at the point where it was going mainstream, then if someone came in that didn't really know about agile and they were just talking about it, and then they would do it within an organization and it would go wrong. And then that organization would go, well, we've tried agile and that doesn't work. And I'd be, well, you haven't really tried agile. You had, some Charlton come in and
Yeah.
that would then set them back. They'd then come back and do agile maybe.
Yeah.
And again, it's like a kind of one argument now, but yeah, so it's an interesting matter.
Sorry, when you were talking about, agile, and I was thinking about how people get caught up in maybe, like this is Scrum, say Safe, and say Kanban, and all of those things, right? I've heard you say it's a knowledge graph is more of an architectural practice rather than a product, right?
Mhm.
So how do you walk like a CDO or a CFO to understand, what the line item is, how they would take a decision on the systems and services are involved in making this happen?
Yeah, so here I would always point people towards the idea of a semantic data product. So while I was at Deutsche Bank and then later on, specifically at UBS, we were basically putting these semantic data products around things. So the data product movement had already kind of started by the time I was at UBS, and people in large organizations at least were trying to think about the data in terms of like it being a data product, which is really good. That kind of shift left thing. It's not, you're basically thinking, okay, other people are going to be wanting to use this information. I need to start thinking about exposing that information for other people to use. The problem with data products on their own is that without semantics, then the whole thing will get very messy and they don't have like a nice way of linking up with each other. So what we did at UBS and is now kind of going across a lot of the banks, that's I'm led to believe, is creating these semantic data products. So I've got a given application. I'm going to put a data product over it, but it's not just going to be a data product on its own. It's going to be a semantic data product. And what differentiates is that the information that it's publishing will be related to a concept within the ontology. So you'll be able to understand the semantics and meaning of what this thing is. Furthermore, you'll be using unique URLs to represent the data item. So if one semantic data product has got information that connects to another semantic data product, then just like on the web, you can put a hyperlink between them. And with that simple architectural pattern, that puts you onto, I believe, the kind of right path. And then in terms of like the vendor tooling, I've kind of sounded really negative for all of the vendors, so I apologize to all the vendors, many of whom are my friends. I'm not in any way negative to the vendors. They're a really important part of the ecosystem. If they're sitting behind or working in conjunction with semantic data products, then everything is fine, and they're like empowerment there. But now you can go swap them out if they're not working for you as an organization. The other thing is and there's a standard that a bunch of us got together and produced called DPROD, which we can go look up. It rolled out first in UBS, but as I say, it's rolled out in a bunch of other places. And that is actually an ontology for describing semantic data products. So that's a really great place for someone to start thinking. If you wanted to think about like this architecture, then go look up DPROD and read through that, or point your AI agent at DPROD and think about how that's going to map in to your organization. I say one final thing here on this one, and it relates back to my kind of like next big prediction about where things are going. So we had the web. So we, the people, put all of our information on the web, and we linked that web together with hyperlinks, like the web's another network. So we did that. Foundational models took all of that information and they compressed it down into this continuous representation of like floating point numbers. Now, for the first time, we had something that kind of looked like a general intelligence. People argue about it, but to me, it looks pretty good like that. That's like kind of like, say web was phase one. Phase two was the compression into the large language models. We're now like maybe in kind of like phase three, which is the organizations realizing they need to consolidate their context. So that context now within the individual organization needs to be consolidated, and they need to learn their model. But there's a phase that comes after this, and everybody needs to have their eyes on that because it's going to be coming faster than most people would think. And that's where the agents go back out onto the web again, and we get the agentic web. So that's why open standards are just so important, because if you just go kind of build your own thing, I'm going to just do my ontology within a database, or I'm going to make my own form up for being what an ontology is, or I'm going to use a product that's got like a proprietary format for it. You're not preparing yourself for the markets of the future, where basically agents will be connecting into this distributed data market. I want to new up some company. All right, so I need like the data product on. It's going to be about clothing manufacturer. I'm going to go pull the data product around that, and I also obviously want a marketing strategy. I'm going to go and pull that, and I want to make sure I'm legally tight. So I'm going to bring that, and then I'm feeding all of that into my AI agent, and then that's coming. That's inevitable. And another thing
So
is,
at what layers would you say, interoperability would be like really important?
yeah, so the base one there, the very simple one there, is you just need to be able to disambiguate something be that a concept in an ontology or
Context of the
or a
client and
data
context of what's up.
or a data item. I need a decentralized way of being able to identify something. That's the starting point. So we need a decentralized way of being able to identify something. Anybody think of a decentralized way of being able to identify anything? Well, URL, right? I mean, you're going to go reinvent that system to do decentralized identification. So it would seem absolutely insane move to make. So yeah, every concept within your ontology should have a unique URL that identifies it and given the
That would
rights of
be like
permission.
discretely very well defined
Yeah,
assets, resources.
as discrete as
Yeah,
you can possibly get, because you've got the DNS system which is globally resolving it. So you've got to go get your names. You've got to go register your namespace, your website from one of the providers. They'll do the first part of the disambiguation, then they'll redirect to your server. Then from there you go handle stuff with your server. So yeah, you're globally discrete.
so we would probably see, like in that sense, a move from, a lot of the patterns today are like servers, right? And clients, right? Whereas you would probably have much more active servers as clients themselves, as agents themselves, where you can then have all of these interconnections actively working together. Whereas earlier it was passive, and you needed a client to actively go and, look up things, right? So this could be a more active participant, and that could also change the paradigm of like how we're using systems even today, right?
Yeah. And then it's the trust boundary around your organization. So that kind of loops back to what we were talking about with the IP thing before. And a theory that I have, that if you can discover your ontological core, so if you know the essence of what you are, you're able to project out almost holographically onto the boundary of what your organization would be. So if that agent swarm is kind of coming in now to a fully linked up organization that knows what its ontological core is, that agent swarm comes in and asks all these questions at these different points within the boundary. It's like the everything's connected together. It's like, I know what you're trying. I know what you're trying to do. Maybe I'm actually going to misdirect you now because you're nefarious.
So this could be some form of a zero knowledge proof
Exactly.
that could
Yeah.
be used in order to authenticate, verify, validate.
Exactly, and there's a version which we're working with a bunch of the, again, investment banks, which the investment banks are sort of like a little like the pharmaceuticals are ahead on the ontological modeling, but the investment banks are kind of a bit more ahead on the data marketplace piece. So we're working on a second version, like the next version, DPROD, that's coming out is going to introduce data contracts in there with this very powerful, quite complicated, but very powerful sort of legal contract language called ODR.
Covenant, like a covenant.
Yeah, like a covenant. Yeah, exactly. And so you can with that. I don't think it's not largely going to be something particularly human authored. I think it's going to be something LLM mediated. But yeah, will allow you to basically say, these are the guarantees that I put out about this data. These are the commitments I make to you. These are the commitments that you must make to me in terms of how it's used. And yeah, then it's like
So some of
a
this,
contract
some of this also
between
sounds like you could use like a blockchain, sort of a description of a
yeah,
system,
you
right?
could. Yeah, I think my
The
own personal take on
contractual
that is
part.
if they want to go like too far on the whole blockchain thing, but yeah, I do think blockchain could play it. As long as we don't
Interesting.
crypto bros in, if you mention the word blockchain, then
Yeah. So contracts and, basically having an immutable log of, what's happening, and the decentralized bit. Like it sounds, the
yeah, I see.
description
Yeah,
of
I think
that
the blockchain
system sounds.
is optional, but it could be useful.
One of the
But it's
things that you
optional.
could reuse potentially.
Interesting. Great. We know we're close to our time now, but one last question. One thing you, if you could change about how enterprises today are implementing AI, one thing, only one thing, and it actually happens tomorrow, what would that be?
That you concentrate on your data first. That's the move to do. Don't do all of these kind of like various prototype projects of all over the place. Just take the AI that we've got now, focus that back in upon your data estate, get your data sorted out and organized. The rest will fall into place. You'll be fine.
That's a very simple yet extremely, simple boring message, which is also what most practical advice is. It's very simple and it's very boring. and it's said time and again, yet it doesn't, yet
Hard
people
to
fail to
become.
follow it.
Yeah.
Yeah.
Cool.
Yeah. But again, Tony, thank you so much for
Thank
taking the
you.
time for
Enjoyable
this.
conversation. Yeah, thank you.
Yeah,
Thanks,
it was a
Tony.
fun conversation. Right? I'll hit stop now. All right.
Okay.